So in lesson 5.6, we are now, remember not so long ago we were solving systems of equations. Now we're going to be solving systems of linear inequalities. So two or more linear inequalities working together, and they have to, whatever solutions there are, has to satisfy both of them. Okay? So solutions to a system of linear inequalities are any ordered pairs making all inequalities true. So when we test a point, it can't just make one of the linear inequalities true. Now it has to make every linear inequality in that system true. Well, where would these be located on a graph? If you have more than one of these systems of linear inequalities on a graph together, where would those solutions be located? Well, they would be located in the overlap shaded region. So you shaded both of them. And wherever that shading overlaps, we would consider that to be a part of the solution region. And the other place that we will find them is on solid boundary lines. I'll say boundary line or lines. We'll do that like this. But we got to be really careful. Only on that part that surrounds the overlap region. So we have two different spots we can look for solutions for our system of linear inequalities. From the shading, where did the shading overlap? And then if there are any solid boundary lines, if they are surrounding, they are part of that overlap region, then we could say that ordered pairs on them are also solutions. Okay? So our first system that we're going to work with today, y is greater than x minus 4, and y is less than or equal to negative 1/2 x plus 2. So we'll graph that, and listen to me really carefully on this part. When you do these, you want to make sure you graph them one at a time. You get one completely graphed before you try to do the other one. Because otherwise you're going to get lost in the, oh, does that go with this, or should I shade, I don't know where I should shade it. So just work with them one at a time. But they're just both going to be on the same graph. Okay, so let's work with our y is greater than x minus 4. Is that in slope-intercept form? Yes. Yes, good news. M is 1. B is negative 4. It's ready to graph. But before we do that, we're going to make a couple of decisions here. Should we have a dashed boundary line or a solid boundary line? Dashed, dotted, whatever you call it. Okay, I call it dashed. You can call it dotted if you want. Dashed line. And then, what do you think? Do you think we should shade above that dashed line or below it? Is greater than. Above, so shade above. These are decisions we have to make, and I need to get you some rulers to use a straight edge. So go ahead and start getting that boundary line graphed. Make lots of points so that you get yourself a nice boundary line, okay? And I wouldn't shade real dark, but just shade lightly. when you do your shading. Now, if you're still not really feeling terribly confident about your shading, which side to shade, this would be the time that you would want to do a test point for just this inequality and say, you know what? Does my test point that I picked from that solution region, not on the boundary line, in the shaded part, does my test point test true? Okay, just for this one. If you're not really sure about your shading yet, it hasn't been going really well. Okay, now let's get ready to graph the other one. It's in what form already? Slope-intercept form. So what is the slope? -1/2. And the y-intercept is 2. When there's a -1/2 slope, that means we can go, what? Talk to me about what -1/2 means when you're making extra points on the graph. You can go down 1. You've used up your negatives, so now you're going to go right 2. Can you go up 1? If you go up 1, then what do you have to do? Go left 2 because you haven't used up your negative. Okay, so let's get that one graphed. Again, lots of points, so you get yourself a nice boundary line. Oh, we didn't make our decision about this one. This will be solid or dashed? Solid, because it has the equal to bar, right? Okay, are we going to shade above or below? Below. Now, don't think that just because one of them is shaded above, the other one has to be shaded below. Don't get into that thought process. Actually evaluate them one at a time. This one is less than, so that means we better shade below. Okay, so after I get my boundary line drawn, and I'm going to shade below. Okay, so where's the actual solution region? Anybody describe it to me? This is the actual solution region. Kind of look like.
Unshaded.
Pardon?
Unshaded.
Unshaded. So just the part that's unshaded would be our solution region? Is that it? You have the part that looks like a greater than. In fact, what I'm going to do is I'm going to take the green, and what you're going to do is with your pencil, you're going to now shade a third time just to show that this is actually right in here. All of this is the solution region, the overlap region. So our overlap region, where were both of them shaded? Because only points that make both of them true get to be considered solutions. Or only points that are on solid boundary lines surrounding this region. So we also have from here, this part of this boundary line right here, those guys would qualify as solutions. Okay. What do you think about this point right here where those two intersect? Don't they have a spot where they intersect and you can tell what that ordered pair is? What is that ordered pair where those two boundary lines intersect? 4, 0. Okay. Do you think that's a solution?
Yes.
It's not a solid boundary line. It's where they intersect. But what's true about one of the lines? It's dashed. I bet it won't make that one true. Let's check it out. Let's check ordered pair out. Just mental math and see if it'll make that dashed one true. That would be the top one, right? So 0 is greater than 4 take away 4. What is 4 take away 4? 0. Is 0 greater than itself?
No.
No. So because even though that ordered pair 4, 0 is on a solid boundary line surrounding that shaded overlap region, because it's also on a dashed boundary line, it doesn't qualify. It will make the other one true, but it won't make that first one true, the one that has the dashed line. Okay, I want us to put this in the graphic calculator and see how we did. Okay? So go turn your graphic calculators back on. put it into the y equal, go to your y equal screen, clear out what you had in there. Let's first put in our x minus 4. And then get it so that it is greater than, go over to the left-hand column and get it so it is greater than. Now remember now, that we're not going to be able, the gravity calculator cannot worry about the dashed and the solid lines, but it can take care of making the boundary line for us, and that's what it's doing right now. Plus then by putting in the, maybe I'm not going to be able to use mine while I have. Okay. By putting in the symbol that is greater than over in the left-hand column, you're taking care of the shading part. Okay, so you have that one in. Now go to y sub 2 and put in our other one. So we're going to now put in negative. Remember, 1/2 when we put in fractions, we put them in parentheses. Parenthesis 1 divided by 2. Remember, use the negative key, which is down to the left of the enter key. Do not use the subtraction key. So use the negative key next to the enter key. Parenthesis 1 divided by 2, parenthesis x plus 2. Press graph and see how we did. Oh, wait a minute, you can't press graph yet. We got to put in our symbol, don't we, for y sub 2. Go back to y equals. I'm sorry. Go back to y equals, and we have to put in the is less than symbol in the left-hand column. Let's go over to the left-hand column. Make it so that the is less than symbol is there. Then press graph and see how we did. Can we put our boundary lines in good locations? And not according to Chase. You forget your x in the second equation. Okay. Did it work? Are we good? Yeah. Okay. So we are going to, though, I didn't make you do test points for each of them, did I? I said you could, if you're still feeling uncomfortable with the shading part, you could do that. What I want us to do now is you are going to do test points, though, for our overlap region. So could somebody give me an ordered pair they believe is a solution to this system? Elena? 0, 0. Okay. So we're going to check ordered pair 0, 0. Let's look and see if that's in our overlap region. Let's double check. Oh, there it is right there. So that looks like a good possibility. So and 0, 0 is a good one to put in because 0 is kind of fun to work with. Y is, I can't remember how it goes. Y is greater than x minus 4. And then we also need to check it in our other one. Y is less than or equal to negative 1/2 x plus 2. We want to leave ourselves enough room to do another one over there too. So 0 is going in for y, and 0 is going in for x. 0 take away 4 is? Negative 4. Is 0 greater than negative 4? Yeah, that's true. So it checks out in that one, doesn't it? Okay, now let's try it in the other one. 0 is less than or equal to a negative 1/2 of 0 plus 2. Well, what's a negative 1/2 times 0? 0. So we end up with 0 is less than or equal to 0 plus 2. 0 plus 2 is 2. Is 0 less than or equal to 2? Is that true or false? True. So it checks out there. Okay? So feeling pretty good about that. Let's do one more. Sure?
Negative 4, 1.
Negative 4, 1. Okay, let's check out negative 4, 1. Let's see where negative 4, 1 is, first of all. 1, 2, 3, 4. Okay, it's right there. So it looks like it's in our overlap region. So negative 4, 1. So again, we do the same thing we just did. We substitute it into both of them. And we have our y is greater than x. I always have to have these written down. I don't want to have to look somewhere else. I want it right above me. So 1 is going in for y, negative 4 is going in for x. What is negative 4 take away 4? Negative 8. That's a true statement or a false statement? That's a true statement. So that one checks out. And now we try our other equation, our inequality. Well, negative 10 to negative 6. Positive half of 4 is 2. We end up with 1 is less than or equal to 4. True or false? True. Okay. Why did we do a couple of them? Because sometimes one of them will check out and the other one won't, and you're like, okay, something might have gone wrong. Or the other thing you do is sometimes you pick a point that's on the boundary line, and then there's trouble with that too. So right now, any questions so far on what because this is what you're going to be doing in your homework. Okay, there's just going to be one thing. We're not going to have time to do the application problem, but we are going to cover that, just that statement at the top here, okay? Because I don't want you to think something went wrong in your homework. If the boundary lines are parallel, they can be, by the way. If the boundary lines are parallel, there can be ordered pair solutions. Or in other words, there can be a solution to it when there is overlap. So the key to systems of linear inequalities is you need overlap. And when there is overlap, that's the solution region. But if there is no overlap, where you shaded each of them and there is no overlap, then there is no solution. You would say, after you're all done, no solution. Okay? Okay, get your graphing calculators turned up and return. Finish up you have to turn in that anticipation reaction guide, so go back now and answer the last column. And it says you have to write why you still agree, why you still disagree, or you changed your mind because, or whatever.